Okay, so this problem here, we're going to look at resolving a force that we have from weight into the amount of force that is parallel and perpendicular to the ramp something's sitting on. When I took physics way back in high school, we didn't do anything with the vectors, and this sort of problem just confused the heck out of me. Once you add vectors to it, this is actually pretty straightforward, but it depends on a little observation that we haven't made before. If you take a vector here, and it can be any vector, I'm going to refer to this as an OP vector, and I'm just making this up as I go along here, so maybe this is 6, 2, and I want to resolve that into two pieces. One is the direction of the I vector, and the other is the direction of the J vector. Those go along the x-axis and the y-axis respectively. They are perpendicular to each other, and they are unit vectors. That makes them something that we refer to as a basis, and in fact something called an orthonormal basis. The super nice property that this has is that if you take OP and dot it with that I vector there, you will get how much of OP points in the same direction as the I vector, which is just this unit 6. Because when you remember that I vector has a 1 and a 0, it's just going to read out what the x-coordinate is and ignore the y-coordinate. Then if you take the OP vector and dot it with J, well, that's going to just read out the part that is parallel to J, the y-axis, and just throw out the part that is orthogonal to it. So that is essentially what we're going to be doing here in this problem. But we've got to first make the observation that the U vector, which is pointing up the hill there, is going to be 8 degrees off of the horizontal, or make it an 8-degree angle with the positive x-axis. So that puts the cosine of 8 degrees and the sine of 8 degrees in those entries if we want to make it into a unit vector. Then we'll make the V vector. Now that needs to be perpendicular to it here, which means it forms a 90-degree angle, and it looks like it is clockwise from it. So that means we're simply going to take cosine negative 82 degrees, that's 8 minus 90, sine negative 82 degrees, and that's going to be our U and V. Now this W vector that we've got here is going to be the weight of the toolbox, and that is just going straight down. There's no x component, and the y component is negative 25. So to see how much of it is going to be parallel to the ramp, then we will just take the W and dot it with the U vector. And you can see that you'll get 0 times that cosine of 8 degrees minus 25 times the sine of 8 degrees. And I'm going to have to use my calculator, and when I do, I get negative 3.479. Of course, all the physicists out there tell me I better put units, and then they grimace because I used English units. They wanted me to use newtons or something. Oh well. For some reason, it seems like math books want to stick to those old English units. All right, so if we do the other part, and this is the force that is perpendicular to the ramp, then we're going to get 0 times the cosine of negative 82 degrees and minus 25 times the sine of the negative 82 degrees. And the calculator says that's going to turn out to be 24.757 pounds. And I didn't follow any particular rounding rules or anything like that. You'd have to adjust it for a real science class.